Hey, so you needed help with the forecast? Don't worry, I'm kind of like an expert, so I can totally help you. Um, Let me get the websites open and then I'll share my screen. Is that okay? Cool, okay. Do you have any gum? You don't? Okay, me neither. I was just wondering. Okay. Okay, I'm finding a few websites to show you. Oh my god, my internet sucks. I went over my band limit, um, bandwidth limit. I don't know what that means, but I guess it means I owe them money. Oh no, the website is down. Oh, it's working. Okay. So I guess we can start by looking at it right now and then we can go from there. Let me share. Um, oh my god, I flipped. Okay, well, that was weird. Um, um, Now I'm uncomfortable. Well, do you want to look at somewhere? Oh my gosh, they also have South America. What is it doing? What even goes on? Um, we have to pick ones that show nighttime because it's not really daytime in a lot of places. I mean, I guess maybe we can see the sunset in South America. Oh, look at it. Yeah. Do you see this? The air goes over the Andes and then it comes back down. And when it hits the top of the mountain, it condenses and then it goes back down and it's dry. I bet it's like a desert. Is it a desert? It's totally a desert. Okay. Yeah, it's also it's called the Atacama. You're welcome. You can look it up. Well, enough of South America cuz we don't live there. I mean, maybe you live there, but I don't. Let's look at North America. Well, there's different places I think that things are happening. Let's look at CONUS. Do you know what CONUS means? Yeah, it's like a cone. It means continental United States. You're so dumb. I'm sorry, I didn't mean that. Okay, let's look at this. Oh my gosh, I could post this on Twitter for 3 likes. Yeah, can you see those storms? They're forming. I think we should zoom in on them. So let's first go here. There might be something here. Let's look at this animated GIF. Oh yeah, check that out. That's awesome. Yeah, the sunset's beautiful. It looks like there's some forming in Oklahoma and a few in Kansas. Look at, we have one called Nighttime Microphysics. Let's click the animation loop. Wow, that looks like trash. They should get a better loop. Alright, how about we go to band 2? Band 1 is fine, but I like band 2 better because it looks better. Wow, you can totally see this, the clouds. Wait, let me show you something crazy. Okay, do you see when the sun sets? The sun is coming in from the west, so you can really see the texture of the clouds. So you just notice some like serious convection and I guess that's like Tishomingo, Mississippi. You probably wouldn't know. There's also a lot of convection in Kansas and some in Oklahoma. You can see the clouds hitting the top of the atmosphere and spreading out. Yeah, it's like they're bubbling. Wow. And then the sun goes away. Tragic. Okay. Now, I like looking at this because this is the upper level water vapor. Do you know what that means? Yeah, it means water vapor in the upper level. So let's go to the animation loop. There's not much water vapor in Kansas, so I can't say that this is probably putting down a lot. But I can say in Mississippi there's quite a bit, and same in Oklahoma. This is pretty interesting. Yeah, it's like boiling up. That's awesome. Do you have any questions? Sorry, I'll use my inside voice next time. Okay. This is where it gets interesting. We need to look at this. So, obviously, there's like, if it's yellow, that means there's a storm, and orange. And if it's green, it's raining. See, like I said, there's a little bit of rain in Kansas. And this is, oh my gosh, should I explain? This is, okay. Saturday. Do you know what Saturday is? Yeah, 4/10, April 10th. Do you know what 0Z means? Sorry, I don't mean to be frustrated that you don't understand. I know that you called me because you need a lesson, so I can help you. Okay, it means Zulu. Yeah, Zulu. Totally. And so, what time zone are you in? I don't know how to convert to that time zone, but I'm in Central Daylight Time. So I'm 5 hours before that. My ear is hurting. 1 second. Okay, it's not hurting anymore. So 0. What's 0 minus 5? So it's 1900. So this is at 7 p.m. Yeah, totally. So Zulu, it's like there's this like city in England called like Greenwich, and for some reason they invented time, so it's all centered on them. So annoying. But so this is 7 p.m. where in the time zone that's the right one for me. Okay, I start and I go from the top and then I go down. That makes sense to me. So let's look at 300 millibar high wind. I'm looking for a U shape. And now it looks like boobs, which is interesting. So what we're looking for is for the winds to go like this. So the reason why we're looking for a U is because this air is from like the North Pole or whatever. Yeah, like Santa brings it down and then it comes down here and it's like super warm here. And like, yeah, it totally causes problems because cold air and warm air, like when you have warm air and then cold air is next to it, it's like not good. Like the atmosphere hates that, so it like mixes it up. Yeah, and like the cold air like goes under the warm air. I can show you in a diagram. Do you want to see? Okay, let me write it out. So, what's your favorite color? Let me get another color. My pen broke. Oh no. Let me try to use it anyway. Okay, it's working. It's broken though, and I got ink on me. Gross. Okay. Let me show you what it looks like. It looks like this. So that cold air goes into that warm air, and cold air, like, it's like cold, right? It's like on the ground. Like, cold air doesn't want to rise, and it gets underneath the warm air and it makes it rise more, and it causes it to start spinning. So what you're looking for on this is for it to go like this, because if it's spreading out in the top, this is the top of the atmosphere, by the way. Did you know that? You did? Oh, okay. So this is like, well, it's the top of the atmosphere where the weather is. So if the air is spreading out like this, it becomes like skinny, and if it's spreading out, it's like more air can rise. So true. Okay. Yeah, because it's like less, if you have like less air on top of you, like, I mean, like, think about it. Like, if somebody's like going like this to you, it's like, oh, like, crap, like, I don't want to rise. But if they just have like a gentle hand on you, or just like a little piece of paper, you can just go boom. Yeah, it's just like that. The atmosphere just behaves like a human being. So we can see it. It's pulling this cold air down. Shall we look into the future? Okay, press forecast loop. Boom. Oh, it's taking a minute to load. Okay. This is not impressive. Well, the trough is impressive. That's what it's called, by the way. Just not the loading time. All right. See, it moves east. Do you know why? Yeah, it's because the Earth is rotating. Duh. Okay, and then we have a ridge-like pattern, and it's bringing in air from like this like gross like desert area. It like pulls it up, and like of course it's gonna be sunny if it's coming from the desert. Like, so you look for the ridge, and it makes like clear weather. I just can't. It looks like a woman's chest. Okay. Let's see. It looks like another storm could come through this week after that. Well, that's a ridge, so it's nothing. It's kind of like stuck. It like got stuck on the mountains. Okay, it looks like here could have severe weather later in the week. But don't trust the model this far out, okay? Don't trust it. Don't trust the model for tomorrow. Okay, now since this looks like kind of a severe event, let's go to a different one. Go to the models and then press high resolution rapid refresh. Yeah, you're welcome. This is a better one. Okay, this is what it says. This model is a CAM. That means convection allowing model. Oh boy. This, instead of like every 3 hours or 6 hours like the other model, this one has one every hour, and it updates every hour. So it's very fresh data. Wow. That's beautiful. Okay. Now, I guess we can look at the 2 meter above ground temperature to see. Do you see it getting colder? It's like moving through and getting cold. Oh, it's gonna get cold. Oh, that sucks. And see this cold air moving through? It could totally make severe weather. Oh my gosh, it's snowing up there. Crazy, crazy frog. Maybe it's snowing. I don't know. Maybe it's just cold. Actually, that just looks like mountaintops. Oh, it gets colder on the mountaintops. Well, that makes sense to me. Alright, this is the 2 meter above ground level dew point. Do they have 700 millibar dew point? Oh, this is the surface. They don't have it. Well, we can just look at 2 meters above ground. That's enough. Oh my gosh, do you see it? It's so dry. It's just this cold, dry air moving through. Oh my gosh, the atmosphere is gonna hate that. This is called the moisture tongue. Cute. Oh my gosh, it could be severe here in like Florida and like South Mississippi, Alabama in a couple days. Interessante. This is 1 hour accumulated QPF. Quantitative and yeah, it looks like it's raining. Yeah, it rained. Oh. Oh, my friends from these areas not going to like that because what time is that at? 12Z minus 5. That's 7 a.m. 6 a.m. 5 a.m. 4 a.m. I just want to see what it looks like in this area. Like, okay, that looks fine to me. I don't really want to explain. Don't trust this. This does not matter. This is called cloud cover. It tells you where there's gonna be clouds, but like, really, like, right, okay. I like that it looks like it's swirly. Hooray. Oh, shucks. Composite reflectivity. You know, let's zoom in on the real action. You go to continental US and you press regional. Look, if you happen to live like somewhere else, oh, this is the her, so you can't have this, but okay, that looks like a place that's gonna have severe weather. Ooh. Ooh. South Mississippi. Yeah, that's some storms. Hooray. 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 Okay. Let's go back to the GFS. See, it's just not as nice and it's like all spread out. Like, why would you ever use that in like an immediate situation anyway? If you want to know about your country, you can go to different continents. Where are you from? China? Yeah, let's look. Wow. Look at that. It's just not like the USA. It just doesn't do the same things. Maybe Europe? What is it doing? Oh. Ooh. Hello. Apparently it's not doing anything. We can look at... I mean, if you're a European, this is your lucky day, because I'm about to tell you what the weather is. Okay, what the hell? I don't know any of these countries. I think that's Spain. I think that's England. Or maybe it's not. Okay, well, if you live in this one and you're on the coast, it looks like you might get some snow mixed precip and it's raining over there. You might get a little rain if you're in Spain. Ooh, a little snowstorm. Cute. The weather here is cute. That's all I can really say about it. It doesn't do like the same things, but It's you need to get a bigger mountain range that runs vertically or whatever, like this, like here, because for reasons I don't really feel like talking about, it makes weather. I mean, like, come on. Okay. Let's look at let's look at did we look at this? We did look at this. Yeah, we looked at that for real. Sorry. My memory. Okay, let's go to back to the her. Oh. They really said F Canada, am I right? Okay. Okay, let's look at the 700 millibar temperature advection. Okay. I don't really mess with this, but I'm kind of interested. Okay, it looks like cold air advection and warm air advection. So, yeah, like, do you see right there? It's like warm and then it's cold. That could produce something. Okay, let's look at some of these features. Okay, this is called CAPE, Convective Available Potential Energy. It's basically like the air can rise because the air around it is like dry and cold. Like if the air around you is dry and cold, like of course you're gonna want to go up. Okay, so you need CAPE doesn't make a storm, but you need enough CAPE for a storm to be there, right? Because you want the storm to go up. Well, why is it only 129? That's like not. I'm just gonna assume that it's wrong. Let me look at this. Yeah, see, this one's saying the surface CAPE is 4,000. Oh, this is 0.3 kilometers above ground level CAPE. Let's try mixed layer CAPE. Oh. That's very high. What can I say? Usually you want it to be, like, if you want a severe storm, like, 1,500 is a good starting place. Yeah, that is very high. Friday, Saturday. Oh, okay. So it seems like in the early morning on Saturday, the severe threat might diminish a bit because there's not enough to support it, like, of energy. But, like, right now, and, like, moving through Saturday, like, Saturday night, there's, like, plenty. So, no worries. Okay. This is called Sin. This is, like, stops the storm from going up. But be careful, because if like something wants to go up and you're like pushing on it and it pushes through, it's like spring loaded, right? Like it go. So a little bit of Sin, good. Like if you have Sin and it goes away, but too much Sin and nothing, it's just stuck. Uh-oh. Sounding failed to load. Probably clicked on the ocean or something. Okay, see, there's a little bit of Sin and it goes away. There's a little bit of Sin. It doesn't really like me right now. Yeah. See, the CAPE isn't that high, though. But you see, it, like, creates this little... This is the temperature going up. And this is, like, an air parcel. This is, like, the environment. And you want the air parcel to be warmer than the environment. But see, the environment might be a little warm, so it like sticks out, and that's like a cap. But if it can break through that, it can be like super powerful. Cool. This is a nice one to look at. A 1 hour maximum updraft helicity. So an updraft is like the part of the storm that goes up. Because there's a part of the storm that goes up, and there's a part of the storm that goes down, and the part of the storm that is going up, if it starts rotating, it can turn into a tornado. I know, right? I know. So we're looking for where it's gonna rotate. So you see it? It could rotate there. Oh. Oh my. Yeah. Looks like some storms in like South Alabama. Wow. South Mississippi. Cool. Okay. So about those sounding, I guess I can explain it. I kind of just explained it, but I'll explain it a little more. I've clicked the wrong place. Let me look for a good place to click it. Okay, maybe... Okay, like here. Okay, ignore this. Well, you don't have to ignore this, but it's wrong sometimes, so... Okay, so this is like what... It looks at like other storms that looked like this, and it makes a guess on what it could be. So it's like, oh, there could be tornadoes. So first I look over here and you see CAPE. That's what I was talking about. It's the convective available potential energy. So it's just the energy of the storm. So like I said, this is an air parcel. So if you had like a blob of air rising from the ground, this is the path it would likely follow. It would look like this. So this is pressure. That's how we measure height. You can also look, it's like 0, 1, 2, 3, or 0, 1, 3, 6, 9, 12, 15. So this is the pressure levels going up the atmosphere, and this is temperature. So if you follow it back down to the ground, you can get the temperature. This is what the environment looks like. So they send up like a balloon, right? And it like catches the data. And yeah, that's how you get this. This green one is the dew point. And when these two touch, it means the temperature and the dew point. When they touch, that means that the air is saturated. So you can look and you see like right there. Oh, you can't see my finger. Like right there. There's probably a cloud right there. And right there, there's some clouds near the surface, which is good. You want some. Sometimes it looks a lot different than this. Obviously, this is not the most severe profile that we will see. So let's try to find one that's a little more severe looking. Okay, this is good. So you want this CAPE line to be on the right hand side of the temperature. So this is the parcel line. It's called a parcel trace. This is the temperature line. You want there to be good amount of space between them so it can rise up to the top. So anything that starts to lift, this is the surface. You have like something down at the bottom, right? Like a blob of air, and it's going up, and at no point is the atmosphere warmer than the parcel. So it can continue to rise because the air around it is colder. So yeah. And look, down at the surface here, you have some serious clouds. But then it gets drier, and so it can continue to rise because moisture will rise over dry air. Very helpful. So this is the surface CAPE and the mixed layer CAPE. again, I'm looking for something over 1500 for these, and it looks like it's over 1500. I'm not that good at math, but yeah. This, you can see this, and it looks like a hook shape like this, which means this is like basically the direction and the speed of the winds with height. So at the surface, it looks like this. Like it starts and it goes here, and then at like 1 kilometer, it the balloon, like the weather balloon, like if it was like tethered here at 1 kilometer, it would be over here. 2 kilometers, it would be over here, and so on. And it goes up to like 6 kilometers. So it makes like this shape. So interestingly enough, when the winds turn clockwise with height, you want the winds to spin counterclockwise in the storm itself. That's how it will work. But when the overall profile looks like it's shifting clockwise, so this looks like a bow and arrow. So like the direction this stick points is the direction the wind is going. So the wind is coming from the south and it's moving north, and as you're going up, it's coming from the east. So at the surface, you have this warm, moist air coming in, and aloft, you have this dry air from the east coming in, and it's going like this. And you have something going up, and you have air going like this. Things are gonna start going like this. Am I right? Am I right? And you want things to go like this, because if you have something like this spinning, and you have air going up from the updraft and air going down from the downdraft, and it's spinning, now you have a tornado. So that's a good thing. Oh, well, sorry, I have the hiccups now. Well, to some people it's a good thing. To the people who get their car hailed on, it's not such a good thing. So now let's talk about this. So precipitable water, that's like if you had it rain in the atmosphere and it rained out all the water. That's how many inches it would rain. It would rain 1.52. I've been told 2 inches is a good amount for severe weather, but I think that 1.5 is enough. It's enough. I don't know what that means. Mean W? Oh, crap. I used to know what W meant. Is that grams per kilogram? W. Is that mixed? Mixing ratio. Is that what it is? That seems pretty high for a mixing ratio. Anyway, lowest relative humidity. Low level relative humidity 96%. Mid level relative humidity 64%. Whatever. D Cape. I guess that's downdraft Cape. I also don't really mess with that. I'm just gonna ignore these. The K index is 31. I like to see a K index of 35, but again, it doesn't really matter because you can still get severe weather. It's just a parameter. Total totals, I like to see a value of 50, and it's 56, so that's pretty indicative. That's just another indices. This is the convective temperature, and this is the max temperature, and you want the convective temperature to be less than the max temperature, and the max temperature is 82 Fahrenheit, and the convective temperature is 76. So I'm pretty sure, wait, I have to subtract. Yeah, I'm pretty sure that the convective temperature is less than the max temperature, so that's good. This is supercell composite parameter. I think you want it to be like, I forgot what you want it to be. Maybe like 3. I don't know. It doesn't say if supercells are gonna form. It's just like, is the environment, like, can they survive? And I think that's high enough. So this is storm relative helicity. You can look up what a good value for that is. I'm pretty sure that 300 to 350 is good. So that's literally this. It's just how is the wind changing with height. And yeah, it looks like there's some helicity. Very nice. I'm not gonna mess with that. And any of these, like, anyway. I could look at this for a second and figure it out, but let's be done. So, I think we've pretty much covered it. So, it looks like for this region, there's going to be severe weather. Let's go back to that precipitation. Oh my gosh, they have simulated infrared satellite. So this is what the satellite might look like in the future. Obviously, it's going to be more wrong as time goes on. Where composite reflectivity? Okay, yeah, let's look and really get. Okay, Arkansas is getting wrecked, and they're getting wrecked again. Arkansas, just consider yourself wrecked. Pretty much all tonight and tomorrow morning. Mississippi also getting wrecked early tomorrow morning. And Florida, Panhandle. Looks like some storms could move through the rest of Florida later on, and there's some, they like break off. Like, did you see that? They like, this thing like broke apart. It's like, oh, I don't want to be with you anymore. Yeah, so later in the week, we could see the same storm moving up through like New York. You know, like it moves through Ohio. There's some storms in Ohio. I wouldn't call those like super severe, but definitely could be some thunderstorms up here later in the week. And these poor guys over here and just getting some drizzly rain and maybe even snow if it gets cold enough. Does that make sense? Do you want to do something else now? This was kind of boring. Okay, do you want... This horse girl gave me like this stick. I think I have to leave. I have to go take a shower. Bye.